Hi, in this example, we're going to discuss a geometric sequence, which will be eventually a series, for an application of a ball being dropped by a certain height, and every time it bounces, it goes a certain distance. So if I went ahead and just drew a little picture of maybe a tennis ball being dropped, and in this case, it says a height of 2 feet from the ground. So let's say this is the ground. So that is the initial distance, right? And it's going to bounce down 2 feet. But when it bounces back up on that first bounce, it's not going to bounce its full 2 feet. It's going to bounce a little less, right? And then it actually goes down that same distance. Right? And then when it bounces back up, it doesn't go that same height again. It goes a little less and bounces down the same distance. So there is a time where the distance up is the same as the distance down. And it continues this process until the ball just keeps bouncing and the distance gets closer and closer and closer to the ground. But remember, the distance from the previous bounce is not the same, and it does whatever it bounces up, it bounces down. So this first bounce up, it goes down and bounces up. We call this this distance will be A1, A2, and these are going to be the terms in our sequence. And for the problem, we're going to have to add them up. Right? Okay. So 2 feet becomes let's kind of look at some terms of our sequence. So the first thing we need to realize is that we have this initial distance of 2 feet, so we'll leave that. But A sub 1 is this next bounce, right? That's A sub 1, meaning that it takes the 2 feet and multiply by 13/14 of that distance. So let's look at A sub 2. A sub 2 takes, now, let's do green. A sub 2 doesn't take the original 2 feet, right? It takes the distance it bounced with A1 and then bounces a little less, 13/14 to be specific. So notice that A sub 2 will be whatever A sub 1 bounced times the 13/14. But if I rewrote A sub 1 with what A sub 1 is, right, that would be 2 times 13/14 times this 13/14, which then becomes simplifying 2 times 13/14 squared. Now let's do just a couple more. I don't want to do a whole bunch, right? But if I did A3 again, that would be do a light color orange. That would be whatever distance A2 went and 13/14 of that distance. So this would just be whatever distance A2 went times the 13/14. But let me rewrite that with what A2 is. A2 is 2 times 13/14 squared times this 13/14. Which ends up being 2 times 13/14 to the third power cubed. And again, if I did A4, I think I can see the pattern now that it's going to be 2 times 13/14 to the fourth, and then so on. And in fact, if I kept going, I would want to recognize that this indice 4 matches the power on the fraction, right? A sub 4 to the fourth power, A sub 3 to the third power, A sub 2 to the second power, and A sub 1 to the first power. We don't always write it, but we know that it's there, right? So tell me what A sub n is. A sub n has to be 2 times 13/14 to the n power. Again, matching the indice with the power. So we kind of need all of these things to really understand what we're going to do now. Like now we understand the ball's bouncing, it's a product, and it ends up being looks like an exponential function in some way, right? And geometric sequences are exponential functions with respect to the indice. So now we are ready. We're ready to do now the problem. So the first problem says, how many times will it bounce before it rebounds is less than 1 foot? So we're looking for this distance here for the ball bouncing to be, it starts at 2 feet and then it starts bouncing, right? It goes up, down. So when would this distance it bounce be less than 1 foot? Well, we can easily see this by taking our a sub n, 2 times 13/14 n. Now remember, a sub n is somewhere in here, right? Where a sub n is going to be less than 1 foot. So we let a sub n be equal to 1 foot, and then we know it has to be less than that, right? So let's go ahead and solve 1 equal to 2 times 13/14 to the nth power. And you're saying, oh no, there's logs again, I just feel it. And the answer is yes, there is, because n is in the exponent. But again, we're pros now at this point, right? That was chapter 4. Like, we're chapter 11 now. So let's go ahead and solve. So we'll have 1/2 equal to 13/14 n to the n power. And we can use natural logs and just easily see that the natural log of 1/2 divided by natural log of 13/14 is going to be equal to n. So let's do that in the calculator and we'll just get an approximation. So once again, we'll do natural log of 1/2, right? And that divided by natural log of 13/14. And just make sure you put the parenthesis, and we get 9.35. So again, remember, it cannot be equal to 1, right? We're looking for the strictly less than a foot. So it would have to bounce past 9 bounces, right? So we would have to say it would have to bounce at least 10 times in order to get the bounce less than 1. Remember, this means that it is equal to 1, but we want it less than. So it has to bounce more than that to get it less than. So we just go to the next integer, which would be at least 10 times, and we'll get the less than 1 foot. The next question talks about how far will the ball travel before it comes rest on the ground. So this is we have to think about this a little bit deeper. So the first thing we need to think about is, well, we don't know how many times it's going to bounce, right? So we need to see that we need to add up all these distances until it hits the ground, right? Let's say it hits the ground here, whatever a sub whatever, I have no idea what that would be. But I would have to add up all these distances, right? But remember that it only went down once at 2 feet. But everything else is doubled, right? Because whatever went up in a sub 1, it went down that way. Went up a sub 2, down that way. So we have to find the sum of the distances, right? But then we have to multiply that by 2 to get all the double bounces, right? But then because it only bounced once at 2 feet, we'll just add 2 feet to it at the end. So it's actually simple, but just thinking about it in a deeper sense, I think, is what is going to be the challenging part. But once we do that, now we can go ahead and calculate it. So some things we need to note. Let me go down a little more. There we go. So this is the second part. we don't know n, and we do know that our ratio is 13/14. So we're going to have to go to what we call the infinite geometric series, right? Because we're looking for the sum, and then that moves into what we call a series. So let's go ahead and go to our textbook and look up the sum of an infinite geometric series. And the reason why we're using this is because we don't know n. If we knew n, then we could go up here and use the finite number of terms, which is here. And notice you have to know n, but we don't know n, so we go to the infinite geometric series. The only condition of using it is seeing that r must be between -1 and 1. And you learn a little bit more about that in Calc 2, but of why that is. But here, it has to be between -1 and 1. Luckily, our r is 13/14, and it is between -1 and 1. So this allows us to use the infinite geometric series, which is this formula here. So if I go ahead and say s is equal to a sub 1 over 1 minus r, okay, so a sub 1 over 1 minus r, given that r is in between -1 and 1, and then it meets these conditions. But this sum, again, is only going to be this sum. So once we evaluate s, we'll multiply it by 2 and then add 2 feet to it. So once again, remember, we're looking for 2 feet plus the sum times 2. So this sum here is the s in the formula. Okay, so I'll just put that there. Okay, I think we're ready. So we know a sub 1. We can grab it from up here. A sub 1 was 2 times 13/14. R is equal to 13/14, and so therefore s is equal to 2 times 13/14 over 1 minus 13/14. And I would go ahead and just put this in the calculator. I wouldn't think about it too much. So parentheses for the numerator, 2 times 13/14. Divided by parenthesis 1 minus 13/14. And that equals 26. But that's not the answer, right? Because the real distance is going to be 2 feet the real answer is going to be the 2 feet plus 26 times 2. Because recall, the s is just the sum here. Okay, so 2 plus 26 times 2, which is 52. 52 plus 2 is 54 feet. And we can verify our answer up here and see that they are correct.